Hi everyone. Today we will be focused on errors. To use the correct terminology, errors that occur during runtime are called exceptions. One of the aim of a developer is to avoid unexpected exceptions or manage potential exceptions that may come up during the execution. And Python offers try except block to handle them. Meanwhile, you can voluntarily raise exceptions for some specific case. A developer should also test his or her program and check if the output is as expected for different input. And to do so, Python offers assert statement. Syntax errors. Syntax error occurs when the code does not obey the syntax rules. For example, if j is equal to 1 without colon, raises a syntax error and prints expected colon. Similarly, if j is equal to 1 colon, print j but without indentation, raises indentation error and prints expected and indented block after if statement. Syntax errors have to be fixed by the developer. Exceptions. Even if a statement or expression is syntactically correct, it may cause an error when you execute it. Errors detected during execution are called exceptions. For example, print A raises a name error if you want to print a variable that you did not define yet, and prints name A is not defined. Or if you want to multiply 4 times fifth element of a list, but your list does not have the fifth element, raises an index error and prints list index out of range. If you want to import pandas, but you did not install panda package, it will raise module not found error and print no module named panda. Or if you want to add a list to an integer, it will raise type error and prints unsupported operand type for addition, integer and list. Handling exceptions. In order to handle exceptions, try and except blocks are used. To start a test on a block of code for errors, begin with a try block. If an exception arises, it will jump to the next block, which is the except block. In except block, we can focus on specific exceptions or catch all the exceptions. There are 2 more optional blocks, the else block and the finally block. The else block runs only if no exceptions are raised in the try block. This is useful for code that should execute if the try block succeeds. On the other hand, finally block always runs. For example, create a function called add2objects and reverse it, and the function takes 2 arguments, O1 and O2. First of all, add O2 to O1, assign to result, get the reverse of the result by slicing, and return the result. But this function may raise a lot of type error exceptions while executing. In order to handle exceptions in this function, we will rewrite our codes. So, we will define add2objects and reverse it function, which takes O1 and O2, but we will implement try and except blocks. In the try block, we will try to add O1 and O2 and assign to result. If it raises a type error exception, print you cannot concatenate a type O1 object and a type O2 object and return none. Otherwise, we will implement another try except block, but before explaining what we do in this second block, let me explain what can we add, what kind of objects can we add. We can concatenate strings, we can concatenate tuples, we can concatenate lists, but we can also add numbers. But on the other hand, we cannot take a slicing of a numbers, but all the others, strings, lists, and tuples, can be sliced. So that's why in the second try block, we will try to get a slicing of the result. And if it raises a type error, print you cannot subscript numbers, return none. If it does not raise an exception, type error exception, return the result. To test my code, I create a list of tuples called test, and let's look at the types of elements of each tuples. List, list string, list dictionary, list integer, integer, tuple. Then for each item in test, unpack the item, create O1 and O2, and call for each O1 and O2 at two objects and reverse it. When I run my codes, as expected, list and list does not raise an exception, but on the other hand, list and string raise an exception. You cannot concatenate list and string. Similarly, you cannot concatenate list and dictionary. Similarly, you cannot concatenate list and integer. And integer raise another exception. You cannot subscript numbers. And the last one, tuples and tuples, does not raise an exception because you can concatenate tuples. Assertion. Assert statement tests if a statement is true. If not true, it stops the execution and raises an assertion error. The syntax is assert plus comparison or logical Boolean operation plus message, but the message is optional. You can also use with try except block. I will take the same example at two objects and reverse it, but this time, while implementing try and except block, I will also implement assert statement. So in try block, I will assert type of O1 and type of O2 are equal, and type of O1 is in the list, string, list, tuple. If assert statement does not raise an assertion error, in this case, return reverse by slicing of O2 plus O1. But if the assert statement raises an assertion error, print both O1 and O2 should be a list or a string or a tuple and return none. To test my code, I will use the same list of tuples called test as in the previous example, and for every item in test, I unpack item, create O1 and O2, I call my function with O1 and O2 and print the result. When I run my code, for the first tuple, which is a list and list, it does not raise an exception, and for the last tuple, which is a tuple and tuple, it does not raise an exception, but for all others, it raises an assertion error exception. Both O1 and O2 should be a list or a string or a tuple. Both O1 and O2 should be a list or a string or a tuple. Wrap up. In this lecture we discovered errors in computer programming, namely syntax errors, which blocks the execution of our codes, and exceptions which rises while executing our codes. In order to get expected results, exceptions should be handled. To handle them, we use try and except blocks. On the other hand, we can implement assert statement as an instrument to test our codes.